Welcome to 4-6, multiplying and dividing monomials. All right, we'll talk about multiplying first. In this slide here that you see, we have 2 to the third power times 2 to the fourth power. Essentially, if we break it down, or we factor the 2 to the third, we have 2 times 2 times 2. Then, if we find the factorization of 2 to the fourth, we have 2 times 2 times 2 times 2. Once again, it's easy to see that the base, the number that's repeating, is 2, and we have 7 of them. So the answer, when we multiply these two numbers, 2 to the third times 2 to the fourth, the answer is 2 to the seventh. All right. The key concept that we just discussed in the previous slide was products of powers. As you can see below, we have the same example, but we don't need to do the factors that we did in the first slide. What we need to is memorize this fact, that whenever we have two bases that are the same and we're multiplying, all we have to do is add their exponents and keep the base. And you can see here quite clearly in the example, in our key concept, we have two numbers multiplied together, 3 squared times 3 to the fourth. We take the base, find the base, which is 3. Then, because we're multiplying, we know that all we have to do is add our exponents, keeping the same base. Now we have 3 to the 6th power. And that, ladies and gentlemen, is products of powers. Before we work out 7 to the third power times 7, just want to talk about a common misconception here. When multiplying powers, do not multiply the bases. So we will not multiply the bases. We'll just identify the bases. So here, I notice that our base is 7. Then I'm going to go ahead and take the first exponent. Because we're multiplying, I'm going to put the addition sign. And even though there is not an exponent there, we can know that there is a 1 there. It's a given. So now we have 3 plus 1 is 4. That's our exponent. Our base is 7. This power is now 7 to the fourth power. Let's do that this time with variables. Notice that we have a variable x to the fifth times x squared. The bases are the same. They're both x. So I'm going to take my base, put it over here. Because we're multiplying, once again, it's the same thing. I am going to take the first exponent and add it to the second. Go ahead and do my addition. And I have x to the 7th power. That, ladies and gentlemen, is multiplying monomials. Alright, on this page we find each product. Well, this time our two numbers being multiplied together are two monomials, but they are mixed. They're not only just constants, but they're also variables with exponents. Alright, so we're going to rewrite this, because we know we can, because we have multiplication. That's what the two parentheses side by side mean. So I'm going to take negative 4 times 2. And then I'm going to take n to the third times n to the 6th. Right here, we're not dealing with exponents, we're just dealing with constants, and this is really easy. Negative 4 times 2 is negative 8. Then I'm going to work on my variables with the exponents. I identified the base as n. The first exponent is 3. Since we're multiplying, I'm going to add the second exponent. Then I'm going to go ahead and do my addition, and now my answer is negative 8 times n to the 9th. Alright, we've done multiplication. Let's do divide monomials. We're going to have problems that kind of look like this. 2 to the 6th power divided by 2 to the 1st power. We can start off like we did with multiplication and use the factors of 2 to the 6th power and 2 to the 1st, and then compare our numerator and denominator, cross out what they have in common. When we cannot cross out anymore, we go ahead and reevaluate, and notice that we have 5 2's, 2 being the base, and 5 being the number of 2's we have as the exponent. Our power is 2 to the 5th power. Let's look at the key concept here, quotient of powers. Well, we can do what we did in the first slide. As you can see, we have an example of it down below here on this one. We can list the factors, or we can use the fact that the key concept is that when we're dividing with bases that are the same, we take their exponents. Instead of adding this time, we will subtract to get our answer. So in the example here, we have 4 to the 5th divided by 4 to the 2nd. What we're actually doing is finding the base, taking the first exponent, or the one on top, and then subtracting it by the one on the bottom, doing our subtraction, and getting our answer. So if you notice, multiplication is addition of exponents, and division is the subtraction. Let's go ahead and take what we learned about dividing powers and find the quotient of these two fractions. Alright, so I'm going to look here at letter A. I'm going to identify that my base is 5. My numerator is 7, so I'll put my exponent in the numerator first. Division, that's what the division bar says, so that means I'm subtracting. Then I'm going to go ahead and take the exponent of the denominator, place that in my subtraction problem. Go ahead and do the subtraction. So I have the base of 5, 7 minus 4 is 3. So our power is 5 to the 3rd power. Alright, problem B. Same thing again. Identify that my base is y. My numerator exponent is 5. That means I'm going to subtract because of the division. I'm going to take my denominator exponent, place it in the subtraction problem. Go ahead and do my subtraction, where my base of y is now y to the 2nd power. And there's my power.